Assalamualaikum warahmatullahi wabarakatuh. I am Nurul Najwa. I will explain about system using compressor. So I will start with introduction first. A compressor is a mechanical device that increases the pressure of a gas by reducing its volume. An air compressor is a specific type of gas compressor. Compressors are similar to pump. Both increase the pressure on a fluid and both can transport the fluid through the pipe. Okay, some of the applications that use compressor is refrigerator, automotive air conditioner, and last but not least is air conditioner compressor. In general, compressors are commonly used in industry to transfer various media and compress working medium in the form of gas. Thus, proper selection and calculation of compressor is required to fit with industry application requirement. Apart from that, the calculation of some simple question will be calculated by using energy balance equation. For the instance, the calculation on heat, temperature, work, pressure, and the rest.
Thank you Najwa for the explanation. Hi, my name is Muhammad Hazim. In this part, I will explain and discuss on how the compressor operates on the refrigeration system and in air conditioner system. First of all, I will go in detail on how compressor functionality and in refrigerator system. Vapor compression refrigeration systems are commonly used in industrial facilities to create environments conducive to the preservation and safe storage of products. Compression refrigeration cycle consists of 4 stages of closed system. The functionality of compressor in full cycle of refrigerator is to control the flow of the refrigerant by acting as a motor and a pump. This allows it to pressurize the refrigerant and reduce its volume. In the first stage of refrigeration cycle, refrigerant enters a compressor as a low pressure vapor. Refrigerant circulates through the system and is compressed and expanded, changing its state from a liquid to vapor. The compressor compresses the refrigerant to high pressure vapor, causing it to become superheated. As the refrigerant changes state, heat is absorbed and expelled to condenser, which turns the vapor into liquid and absorbs some of the heat. There are different types of compressor of refrigeration application, including reciprocating, rotary, and centrifugal compressor are the most common in refrigeration unit. This is a diagram of refrigerator compressor in full cycle. In the other hand, the compressor in air conditioner work in different ways. Air conditioner system works by transforming a refrigerant from a gas to liquid and back again in continuous cycle. Compression air conditioner cycle consists of 4 basic parts, including compressor, condenser, expansion valve, and evaporator. The functionality of compressor in full cycle of air conditioner is the heart of cooling cycle. In the first stage of cycle, compressor starts working to pressurize and compress the low pressure gas refrigerant from the inlet. The motor driven compressor function is to push the refrigerant gas, rising from its temperature and pressure so that it exits the compressor as a hot high pressure gas. The compressor pushes the hot gas to the fin condenser coil in outlet of the air conditioner where fans blow cool outside air over the coil through the fins. This is the diagram of air conditioner compressor in full cycle. That's all from me. I will give it to Fakro to the next part.
Assalamualaikum warahmatullahi wabarakatuh. Okay, next I will explain about the first and second law related. First law of thermodynamic is an expression of the conservation of energy principle. The first law of thermodynamics states that change in initial energy of system equals the net heat transfer into the system plus the net work done on the system. Since the compressor is an open system, it undergoes a somewhat idealized process called the steady flow process. Hence, the total energy constant of a control volume remains constant. The energy balance for a general steady flow system can be also written as Q dot minus W dot equal to total out M dot multiplied by H plus V squared per 2 plus GZ minus total in M dot multiplied by H plus V squared per 2 plus GZ. In idealized condition, heat transfer in the compressor is negligible due because of insulation. Therefore, Q equal to 0. Next, the potential height of compressor does not change as there are no evolution of depression. Thus, GZ equal to 0. And lastly, the kinetic change in the compressor is also negligible since the change does not contribute any significant effect. Therefore, V squared per 2 equal to 0. So, based on the assumption above, the energy balance for a compressor is expressed as negative W equal to HAZ minus H inlet in kilojoule per kg. Let's proceed to the second law of thermodynamic. According to the second law of thermodynamic, heat will always flow spontaneously from hot to cold and never the other way around. A refrigerator causes heat to flow from cold to hot by inputting water, which also the space inside the refrigerator. It does this by following the steps below. First step is work is inputted, which compresses a coolant. Second, heat flows from this coolant to the air in the room, reducing the temperature of the coolant. Third, the coolant expands and it cools down below the temperature inside the refrigerator. And the last step is heat flows from the refrigerator to the coolant, decreasing the temperature inside. This process is cyclical and allows the refrigerator to be run for as long as necessary. The word needed as input to the system is given by the equation with the variable. So that's all for me. Thank you.
Okay, good morning everyone. I'm Yai Ping. Today I want to discuss some calculation in our presentation. And so here's the question. Refrigerant 134A enters a compressor with a mass flow rate of kilogram per second and a negligible velocity. The refrigerant enters the compressor as a saturated vapor at 16 degrees Celsius and leaves the compressor at 1400 kPa with an enthalpy of 281.39 kJ per kg and a velocity of 50 meter per second. And the rate of work done on the refrigerator is measured to be 132.4 kilowatts. If the elevation change between the compressor and inlet and outlet is negligible, determine the rate of heat transfer associated with this process in kilowatt. So this is the example diagram for this question, and this is the inlet position, and this is the work input. The W dot in is 132.4 kilowatts, and for the outlet, so we need to find the Q dot out, which is also the rate of heat transfer with this process. Okay, so for the inlet position, we need to find the enthalpy for the inlet and also inlet position, and also for the specific volume. So from the saturated R134A temperature table, we knew that the temperature in the inlet position is 16 degrees Celsius, and we can knew that P saturated in 16 degrees Celsius is 0.50416 megapascal, which is taken from the table. And since the phase is saturated vapor, which is already mentioned in the question, so we need to refer to the superheated vapor R134A table. So we can knew that the H1 also equal to Hg in 16 degrees Celsius, so also equal to 256.22 kJ per kg. While for the specific volume in the inner position, it is also equal to Vg in 16 degrees Celsius. So the specific volume for the inner position, or V1, is 0.0405 meter cube per kg. While for the outlet, so we also need to refer for the saturated R134A pressure table. So the pressure given is 1400 kPa. So we can know that the T saturated is a negative 18.8 degrees Celsius, and also the Hg is equal to 236.04 kJ per kg. So since the enthalpy in the outlet position is already given, so we can know that the H2 is higher than the Hg, because the H2 is 281.39 kJ per kg. So we can assume that this is a superheated vapor phase. So after that, we need to find the specific volume in the outlet position. So we can using interpolation to find out what is the specific volume in outlet position. So by using the interpolation, by comparing to the enthalpy from the table, by comparing them and after the interpolation, we can get V2 is equal to 0.19902 meter cube per kg. We need to find T2. So T2 we can use interpolation by comparing to the table just now. So we can comparing to the H2, and also we can also compare to the V2. So for this one, I use enthalpy 1. So by comparing to the H2, so we can get T2 is 64.47 degrees Celsius. So finally, for the energy balance equation, which is also in the web form, we obtain this formula, which is V dot in minus Q dot out plus M dot multiplied by H1 plus V1 power 2 and divided by 2 equals to M dot multiplied by H2 plus V2 power 2 and divided by 2. So V1 we can assume it is approximately 0. So finally we can find out Q dot out is equal to 0.3 kilowatts. So therefore the heat transfer is very small, so which means the process for this system is nearly undiabatic. So that's all for me. And next, my teammates will discuss more about the PV and TV graph. And that's all for me. Thank you.
Assalamualaikum, my name is Nurul Fatujana. Today I will explain about T versus V graph and P versus V graph. We can find V1 from the graph. From the question, we know the place for inlet is saturated vapor, so the volume for inlet is equal to Vg at temperature 16 Celsius and the H1 equal to Hg at 16 Celsius. For the outlet, since the H2 greater than Hg at pressure 1400 kPa, the phase for outlet is superheated vapor, and the V2 point will be at outside the saturated vapor line. From the graph, we also can see the pressure at inlet or P1 is greater than the pressure at outlet or P2, while the temperature at the outlet T2 is higher than the temperature at inlet T1.